All right, now that you're a master of adding linear expressions, let's move on to subtracting linear expressions. It says here on page 404 that when you subtract linear functions, distribute a -1 to the second expression, then follow the steps for adding linear expressions. Don't forget to follow the integer rules. Now, basically what this means is there's one additional step when you are subtracting linear expressions than there is when you're adding them. So basically we're doing the same thing you were just doing except for one thing, and that is distributing a -1 to the second expression. So let's take a look at example number 1 and see what that exactly means. Example 1 says subtract positive 6x plus 3 in the first parentheses, and then there's a minus sign. Before that was a plus sign. Now it's a minus sign. That's why this is called subtracting linear expressions. And then the second expression is 2x plus 2. Everything looks identical to what we were just doing with adding linear expressions, except this minus sign in the center. Well, that minus sign doesn't just apply to the 2x. It also applies to the positive 2. It is like our distributive property, and you must distribute it to both terms in the parentheses. So it's like there's an understood 1 here, and you would take -1 times positive 2, which changes 2x to a -2x. And then you would also distribute the -1 to the positive 2, and that would make that a -2. So basically, the signs in the parentheses both changed. You went from a positive 2x to a -2x. You went from a positive 2 to a -2. This negative up here in between is now gone. We distributed it. We're no longer going to pay attention to it. This becomes like an addition of linear expressions problem. And we can just bring the -2x minus 2 over and put it underneath the 6x plus 3. Notice our signs are different in our constants. So this is like 3 minus 2. Take the sign of the bigger looking number, so it's positive 1. 6x minus 2x, 4x, and again, taking the sign of the bigger looking 6x makes it positive. So our simplified linear expression is 4x plus 1. So again, you're distributing an understood -1 to the 2x, making it -2x. You're distributing a -1 to the positive 2, making it a -2. And then you're treating it like it's an addition of linear expressions problem, even though our integer rules say we had to subtract. Let's take a look at example number 2. 2x minus 3 in parentheses. There's that negative in between, and then x minus 2. Again, we're going to distribute an understood -1 to what is in parentheses. -1 times x makes it -x. -1 times a -2 will make it a positive 2. Notice that in the parentheses, x was positive, but now it is negative. Notice that the 2 was negative, but now it is positive. This negative sign outside the parentheses is going to change the signs of what is in parentheses. Now we can drag this one over and put it underneath the first one, making sure we bring our signs with us. We have a -3 and a positive 2. Different signs say we're going to subtract and take the sign of the bigger looking number. The bigger looking number being the -3 makes this a negative sign. 3 minus 2 makes it 1. 2x and -x also have different signs. So again, we're going to subtract, and keeping in mind that there's an understood 1 there, that's 2 minus 1x, which is 1x, but we don't write the 1, it's understood. We're just going to write x. And again, the bigger looking number was positive in that subtraction, so it's going to be a positive x. So our simplified linear expression is x minus 1. That should prepare you to do letters A and B, but let's go ahead and go on to example number 3. It says find, parentheses, negative 2x minus 4, close parentheses, minus 2x. It says use models if needed, but since we have not been practicing using models, I think that would only confuse you. But just like in examples 1 and 2, we're going to use this negative sign outside here and treat it like it is in a negative 1 and distribute it to what is in parentheses, making our positive 2x a negative 2x. We can then bring it over under the other negative 2x, and if it makes you feel more comfortable, you can put a plus 0 here to make it line up on the right. Adding 0 to anything does not change what it was. So a negative 4 plus 0 is still going to be a negative 4. So we can just drop that down. And then negative 2x and negative 2x. Well, those are same signs. So the rule says that when we have same signs, we add and we keep the sign. So the answer is going to be negative, and 2 plus 2 is 4. Don't forget your x. So our simplified linear expression is negative 4x minus 4. So that should get you ready for letters C and D. But again, we're going to move on and do some additional examples. Notice they're not giving you a space to do models now. So 6x plus 5 negative 3x plus 1. You distribute that negative as if it's a negative 1, changing 3x to negative 3x. You distribute that negative to positive 1, changing it to a negative 1. And again, notice it just changes the signs of the numbers and terms in the parentheses. Then we can drag that over, negative 3x minus 1 underneath. Our constants have different signs, so we're going to subtract and take the sign of the bigger looking 5. So 5 minus 1 is 4. Our coefficients have different signs, so we're going to take the sign of the bigger looking 6x, subtract 3x, and we end up with positive 3x plus 4. Example 5 says negative 4x minus 7. There's that subtraction or that negative. And then negative 5x minus 2. It's an awful lot of negatives, huh? But watch what happens. When I distribute that negative in, negative times a negative equals a positive. Same signs, positive in multiplication. So negative 5x becomes positive 5x. Distribute that negative to the second term, negative 2. And again, a negative times a negative equals a positive. So having a negative outside the parentheses changes the signs of the terms in the parentheses. Then I can drag it over. And I ask myself, do I have same signs or different signs? Well, negative 7, positive 2, different signs. Taking the sign of the bigger looking number means this is going to be negative, and 7 minus 2 is 5. Positive 5x and negative 4x, different signs, but taking the sign of the bigger looking number when we subtract, it'll be positive. 5x minus 4x is 1x, but remember, we don't put 1x. The 1 is understood, so it would just be x minus 5. That brings you up to examples E and F that you can do on your own after the video, but we still have one more example to look at. It says, a hat store tracks the sale of college and professional team hats for M months. Hey, there's our variable. M stands for the number of months. The number of college hats sold is represented by 6M plus 3. So college hats is 6M plus 3. The number of professional hats sold is represented by 5M minus 2. So professional hats, 5M minus 2. Write an expression to show how many more college hats were sold than professional hats. So how many more college hats than professional hats? So which were there more of sold? Yeah, the college hats. So when we write our expression that is going to be a subtraction expression, it's going to be college hats, 6M plus 3, minus professional hats, 5M minus 2. Then we need to simplify the expression before we evaluate this expression as if M equals 10, and it would not be 10 hats, it would just be 10. So first things first, we have a minus sign in the middle, so we need to distribute that, making 5M a negative 5M, and making our negative 2 into a positive 2. Then we can drag it over and put negative 5M under 6M and positive 2 under 3. 3 and 2 are both positive, so it's going to be an addition problem and positive 5. 6 and negative 5M are different signs, but the bigger looking number is positive, so when we subtract, we're going to end up with a positive M. And remember, the 1 is understood, so we do not write a 1. Now we can go back and find out exactly how many more hats were sold by the college teams than by the professional teams by plugging a 10 in for M, and we would do 10 plus 5 equals 15 more college hats than professional. Alrighty, so that gets us through our last example. You should go on and complete the letter problems that we will go over together.